Hi, my name is Josue Batista. I am a business and technology strategist. Welcome to this segment of What and Why First. In this segment, we're going to explore 3D printing as one of the 7 emerging technologies that are changing the world. Since Charles Chuck Hall created 3D printing more than 30 years ago, the technology has evolved and expanded into several fields of industry. From bioprinting of human organs to building prototypes for industrial manufacturing, 3D is one of the most fascinating and promising emerging technologies. From my research, bioprinting is still a few years away from cost-effective applications. Now, from an industrial manufacturing side, 3D printing is taking off. The application of 3D printing in manufacturing is called additive manufacturing, and there is a very important framework introduced by Deloitte in 2016 called the digital thread additive manufacturing. I think it is important that we gain an understanding of what digital thread additive manufacturing is and why it is important. First of all, the digital thread is that single seamless strand of data that stretches from the initial 3D design concept to the physical part. Another way to see it is the digital thread is that series of complex, connected, and data-driven events from the digital to the physical creation of a part using additive manufacturing. Why is it important? Well, additive manufacturing processes must scale at the industrial level. They need to move from specialized, limited footprints to mass adoptions at the global level. For that to happen, that digital thread must exist. With that digital thread, additive manufacturing will move from the current state, being physical or hardware-associated production, to a more data or record management paradigm. In other words, rather than shipping parts, their value is in shipping data. Of course, there are challenges with that. How could it be possible, for example, to create and manage that digital thread across the supply chain without being exposed to malicious actors who might tamper or steal the data? Also, how could one maintain the integrity of the digital thread across a distributed model with multiple partners that do not necessarily trust each other across disparate graphical locations? Well, you should not be surprised these challenges have the potential to be solved using blockchain technology. Blockchain could serve as the backbone and security layer for that digital thread additive manufacturing, underpinning all the transactions that occurred throughout the digital and physical life cycle for additive manufacturing. And here are 5 characteristics of blockchain that are relevant to additive manufacturing. The first one is that blockchains are distributed. That means that data is maintained within and among the stakeholders. That is important for additive manufacturing because it helps in the management of activities in distributed supply chains. Secondly, blockchain technology are getting faster with no need for miners. So settlements and exchange are nearly instant. In additive manufacturing, changes to the design are made instantly, which facilitates efficiency in the process. Number 3 is that blockchains operates in a trustless environment using cryptography for validation and transactions that offers protections against risks of unauthorized data access. The fourth element is blockchain transactions are irreversible. Transaction history is append only. Also, blockchains is censorship resistant. Modifying the past transactions would be expensive and immediately detected. Those 2 last characteristics of blockchain will help with cyber risks and intellectual property protection that are intended to provide an indelible and traceable change of records. With blockchain, the future of digital thread additive manufacturing is bright. I encourage you to learn more about digital thread additive manufacturing and blockchain. To get started, just follow the links to additional resources and information in these video posts. Until next time, cheers!